So now we're going to start writing this function here, and that's like what's going to happen when we press this button. So the story goes, we loaded inputs and we forward propagated through the network, and we got an output here. We have an expected value, and the delta is just going to be the difference between these two. I'm not sure about the sign on this one, and the MSC is like going to be a clean-up version of the delta, which is only positive. And the delta gradient is how much this delta changes with respect to this output. And yeah, more on this later. I'll just code that now, and then we can talk about it later. So the delta is going to be calculated from the expected value minus the output. And there's going to be a neuron there. And then the MSE, mean squared error, is going to be calculated by taking half of the delta squared. And the delta gradient is the delta times the transfer function derivative of the output. And there is only one output here. This does not work if we have more than one output neuron, but for now this works. So let's write this derivative now, and I realized that this hyperbolic tan transfer function is not used as often as the sigmoid, so I'll just put in the sigmoid here instead. I think from what I read, that doesn't seem to be super important which one you use. They're kind of similar. It's more like an optimization problem. And then we're gonna just write out this one and write the derivative below here. Taking y. So that is basically like the transfer function times 1 minus the transfer function. So let's see if it works. Load inputs, fprop1, fprop2. So we get some delta MSE and delta gradient. So we're gonna update these delta weights that we get when we press the button. We're gonna multiply the output here with the delta gradient for each neuron. So without going into too much detail, let's start writing that. So we have 4 neurons in layer 1. And the result of this backpropagation is going to be an output that we take from this layer, and we are going to multiply this with the delta gradient. And then we're going to set the synapse, the corresponding synapse, with this new value that we have calculated. So let's see if it works now. Load inputs for propagate, calculate error, backpropagate. So we can see that the synapse here has gotten a bigger delta weight than the ones here, and that is because the network now correctly assumes that this synapse has been more responsible for this error and should be punished more. So now we can continue with the backprop to go over to these two sets of synapses. And that's going to be like a several part calculation, and it's actually like the most complicated part of the whole thing to write. So we'll take it step by step. So the first step is like kind of similar to the one that we did here. So we got this delta weight by multiplying this delta gradient here with the output. But now we want to take this delta gradient and multiply with the derivative of this output with regard to this transfer function here. And that's because like we could imagine ourselves standing over here right now, but we want to end up on this side of the neuron, so that we will be in this area, and then we have to like put it through the transfer function, and then we have to take this value and multiply with the weights here, or this weight here. In this case, we're over here, and that is because like if we're gonna update these delta weights, we can see that the error can come from like 4 different places here. So it's like distributed somehow, so we need to take regard of that. Like when we updated these delta weights, the error can only come from one place, so we didn't really have to care about like how big this weight was. So we need to use this here. So we multiply this value with the weight, and then we also need to multiply with the output here to find the delta weight here. And that is like the same as we did here. So let's start writing this. I can actually take up a picture of the net here so we can take a look at it at the same time. So we're gonna have 2 nested loops, or 1 nested loop, I don't know, in range 0 to 2. That is for layer 0. We're going to do this on 2 neurons in layer 0. And then we're going to have another loop here. That's going to run 4 times. That's for the layer in the middle. So we need access to all the neurons in layer 1. So that's 4 of those, and we also need access to layer 0's neurons, which is the I index here. So part 1 of this calculation is basically the same thing as above, the one we did above, but instead of taking the output, we just take the derivative of the output instead. And then we're gonna multiply this with the delta gradient in layer 2. And then we have part 2, which is the weight. In layer 1, so that was this way here. And then part 3 is the output. And here's when we use this neuron here. So that's the 3 parts of this calculation, and then the result is all these parts put together. And then we're going to set the synapse to the new value we have gotten. So these is the synapses between layer 0 and layer 1, on index ij, and we're gonna set the delta weights with the result. So before we move on, I'm gonna make some improvements to the GUI, and I already made these Q-line edits a bit wider so that they don't overflow when the weights are updated, and these labels a bit bigger. So that's done here in here. Like, you can change the weight of the width of the weights here, and buttons, labels, stuff like that you can do inside the buttons method here. So we're also going to put in a bunch of new labels to make it more readable, and that is done in here, and I pre-made some changes that I'm just gonna copy paste in here. I can also take away these two, and let's see how it looks like this. And we're also gonna change this Q-line edit up here a bit so that it doesn't just display one thing but two things. Q-line edit, that only displays one line, so in order to display many lines we're gonna change it to text edit on this here, and then we're also gonna change some stuff here to make it display like another thing, and that's the batch delta weight. I'll get into it later what that means and what we're gonna do with it, and that is going to be taken from the Synapse class, and so here when we're gonna update the text box, we're gonna put in some other stuff. So we're not just gonna display this one, we're also gonna do an append here, and this is gonna start on a new line automatically. So we're gonna do the same thing here, down here, but for the other layer here, and this one is gonna be pretty much exactly the same. Okay, so this should be batch delta weight, obviously, so we can change that. And now we're gonna write the update weights function here, and in order to update the weights we need the delta weights, and I'm just gonna write a method to get the delta weights, and we can copy paste from get weights because it's very similar. Get delta weight, and then we just need to change like the word here to delta weight instead of weight. We don't really need either of these methods because the controller has complete access to the synapses, but it's pretty neat to still not have to write this whole line when you get it, and yeah, for consistency's sake we can continue doing this. Now let's write the update weights. So we will like do it hard-coded style like everything else. So update first set for I in range 0 to 2, for j in range 0 to 4. So we need the weight, get weight, and we're gonna take that from the first set, and we're gonna take it from ij, and then we're gonna take the weight change, and that is gonna be calculated from taking the learning rate, which we haven't written yet, and then we're gonna times that the delta weight, get delta weight from index ij in the first set, and then can move on to the next line here. We're gonna add this to something called the momentum, which we also haven't written yet, and that is going to be multiplied by weight. We're actually not gonna use this for now, but yeah, we'll still have to write it. Weight change, and then we're gonna set this synopsis ij. We're gonna set the weight with the weight. Okay, so let's go up and add these terms now. Up here, we can put them up here. Learning rate. So we're gonna initialize it to 1 and momentum to 0, and the learning rate we're gonna do it to 1 so that nothing changes with the learning rate initially, so that it's easier to understand. And now we can do the second set. It's gonna be like pretty much the same thing. So second, and we're not going to use 2 loops here as before. Use the I index here, and wait. So we take this from the first or the second set. Learning rate, and here's the number 1 here. Momentum, and we're gonna change these ones. Okay, so this should be 0 obviously, and let's see. Okay, so we haven't set the number of digits, I guess. So we go into the controller and update line edits. So here we need to round this like we have done here. And yeah, I can use like 4, I guess. And the same should be done down here. So let's see. So delta weight minus 0.06, and this is 0.01. So after the update, this should be minus 0.05, which it is. And here, yeah, the change was really small here, so I guess it was doing the right thing. And now we're pretty much done. We are obviously not gonna cycle through all this every time we load new inputs. So we're gonna have a button that does that automatically. And we're also going to use batch learning and update this one so that it shows the right thing. So we'll do that now, and that is basically done here. When we backpropping, we're not just gonna update the delta weight, we're also gonna update the batch delta weight. Get attribute I0 and yeah, batch delta weight. So yes, I guess that's done, and then we're gonna do pretty much the exact same thing in the next one. Here's gonna be 0, 1. IJ. So this should be J here. So yeah, you can see that batch delta weight is basically a summation of all the previous delta weights. So you use that when you don't want to update the weights straight away. That's called pattern learning. You actually want to use it when you want to wait with updating the weights, and that's batch learning. And now we can put in a button that will run through all the data. So we're gonna put it here, under here. Just copy paste here, and we're gonna call it run epoch button. So epoch means that you run through the data one time, and we have to write a function that does that, run epoch. So we'll put that in the net at the bottom here, epoch, and then we're going to initialize this button the same way as we've done the other ones. Run epoch. So we'll put it at the top left corner. Run epoch. So now we're gonna write this run epoch, and yeah, basically we're gonna have to change some things to make this work. Like in training data, we're gonna have to have functionality for like knowing when we have reached the end of the file. So we'll have to put that in here, but we can do that soon. We can start by like putting in this local variable here. Is there is data. We initialize that to true, and while there is data, we're gonna load inputs. So load inputs at the moment is not returning anything, but we're gonna write it so that it returns stuff. So basically, if it fails to load any inputs, it's gonna return false. And how is it gonna do that? And that it's gonna get this like stuff from this class. So we're gonna have to write like an if statement here. So it reads a line, and if the length of this line is 0, then it can return a list of zeros, because this is going to be like the sign that we have not found anything on this line, and else do all this other stuff. So now this class is returning something, and then we can continue to look at the load inputs here. So we have to write an if and else here as well. So basically, if this inputs equals this list that we just created, then we return false. So there is no inputs, else do all this other stuff and return true. And that's it. So here we're gonna continue. So we assume that this returns true or false now. If there is data is false, then we're gonna update. So this is where like the batch learning approach kicks in here. We don't update until we have reached the end of the file. Epoch done. Else we do this whole cycle, or whatever we're gonna call it, like forward prop L0 L1, forward prop L1 L2, calculate MSC, BackProp layer 2 to layer 1, BackProp layer 1 to layer 0, and then we gonna print so that we know that we've done here one cycle. Or actually we're not going to use the word cycle, because I think it's sometimes it's used as a synonym to epoch, and I'm just going to call it lap instead. $1.15. Let's see how it works now. So yeah, we get the same results as we did previously. This is minus 0.05. Now I'm going to make some improvements to the GUI. I'm going to color the neurons, and I'm going to draw some arrows between the buttons here so that it's clear which one that goes after which. So since we're not using designer, we are going to do the neuron drawing in here by using a brush, set brush. So like before you draw the actual ellipses, you just set the filling for the ellipses to some color, and I just pre-checked some of these. And now we're going to draw the arrows between the buttons. And actually I realized like how this should have been done from the beginning. Yeah, like without the designer, like you could actually draw the whole image of this in a paint program, and then just use that picture as a background. because like when you do that, these dynamic buttons in Qline edits, they always appear on top. So that would have been much easier than to paint everything in PyQt. So I'm just gonna print screen this one, and then I'm gonna open my Paint program. I'm just using Windows Paint, and I'm gonna paste this. So I'm gonna move this to top left corner here, and we have to make this smaller. So now we just want to fit in the image just like it appears in the program, and yeah, we can see here that we have at the bottom here we have not the same amount of pixels as in the program. So now you can just like draw anything you want in here. Like I'm gonna draw some lines between the buttons here, and yeah, I don't know, I'm just gonna use some random color, I guess. Size big. And here there are two paths. Like you can either update directly, which is pattern learning, or you can wait with updating and load the next inputs, and that is batch learning. So now I'm just going to save this and yeah, put it in the same directory as your Python project, and I'm just going to name this my pick, and PNG is fine. And now we go back to the program. So like up here, or yeah, I guess it could be here. You can now create a variable with this picture. It's going to be QLabel. Set the geometry. We set it to the exact same parameters as the window. 0, 0, so it starts at the top left corner. And then we're gonna set a pix map. Qpix map os get command window. And now we're gonna put in the path of this picture, my pick, PNG, and we have to import the OS. So now we run it. Yeah, so this is how it looks now, and yeah, you can see how easy it was to import an image and just put it in here, and yeah, so basically, unless you really have to draw inside the program, you just use a painter and import the image instead. Now we're gonna make it so that when we click a button, it's gonna remain like in a checked. It's gonna look like it's checked until another button is pressed, and that is something we can do when we create the buttons. So we need to like add a button group. Q button group. And then we have to do two things with each button, and we're gonna set it to checkable, and we're gonna add it to the button group, and then everything else is pretty much automatically taken care of. And yeah, obviously this should have been done in a function because there's gonna be like so much code here, but yeah, it's I'm not gonna do that now, at least. So set checkable to true, and then we're gonna add the button. Oh wait, button group. Add button. So now we added the button to the group. So yeah, this is gonna be done for each and every one of these. Run epoch. Maybe we'll wait with the run epoch for now. So load imp. So this is where we are. So we're gonna have two update weights buttons, one for batch and one for pattern. So we're gonna change the name of this one, update weights button, to update P for pattern weights button, and replace all. So yeah, and then we're gonna change this update weights function a bit so that it's not just going to take in one parameter but two, and we're going to have to rewrite this so that it operates based on what type of weight we're updating with, delta weight or batch delta weight. So we can start by writing it here. So we're going to have the partial here. And then we have to include the parameter here. We're going to call it delta weight for this case, and that's pretty much it. And then we can start building our next button, which is going to be the batch one. So we put in a B here instead, and then we just put in batch delta weight here. And we're gonna go back into the net here and write this function here, with a parameter. So we're gonna get a string from here that says either delta weight or batch delta weight, and we have to parse this string somehow. So we're gonna do that inside here. So we're going to evaluate the string, and so we're going to basically we're going to build up this string from scratch based on whether it's batch or delta. I'm actually not sure that we have the get batch delta weight. Okay, we'll have to put that in here. Yeah, again, we don't have to really write this get method, but we'll do it here. So get batch delta weight, and then we're going to have batch here. Okay, so it's either going to say get delta weight or get batch delta weight. So the parse type is going to look like this: self dot get, and then we're going to add this type that we're putting in here. And then we're going to continue writing this string here, which is 0 plus the string I plus comma plus string j plus parenthesis. And then we're gonna use that here instead. Parse type. and the same is going to be done down here. And since we're not using 2 indexes here, we're going to use just 1, and it's going to look something like this. String in here, it's going to be a 1 instead, because it's this set number 1, and I think that should be alright. So I'm going to initialize the batch button now. It's going to look pretty much exactly the same as the pattern one. We can name this one P and this one B. And we're going to put this button right under the run epoch button. 65. And yeah, we can put in some spaces here between these. We're also going to add this run epoch button to the group. Because there's only one button that can be clicked at one time, so it makes sense to have all of them in the group. And yeah, we also have to when we run the epoch here it needs a type now, so we need to create a variable inside the net here that gives the type of update that we want to have. So that's going to be like an initialization parameter here, and we'll start by doing the batch delta weight one. The other type is just delta weight, and that's the pattern learning. So let's see what happens. Run epoch. Okay, so it runs through the data and prints out epoch done. We only have 1 data point, so let's put in some more. Let's do 4. Let's see what happens. So run epoch, and the problem now is that when we have read the whole file, text file, we're like standing at the end here, and when we press that button again, it's yeah, it basically thinks that we're still at the end here. So we have to include functionality for it to move up to the beginning of the text file. So to do that, we're gonna have a function that we haven't written yet. So here we're gonna go into the training data and move to top of file, and that is going to be like here somewhere. So basically here, like super easy, move to top of file. And self text file dot seek 0. So run epoch, and yeah, it loads. Oh, it actually updates the weights as well. But yeah, we can actually see if this works now. We'll have to uncomment or comment away this one to see what's going on, so that it doesn't update the weights automatically, so that we do that. And yeah, our training data is super simple. So let's see if this this works. So we haven't randomized the weights, but it shouldn't really matter in this case because it's so easy. So yeah, we run through all the data one time. Let's see what it says. So the expected value is 0, and this is just for the latest data, so it's basically this line. Yeah, the interesting is the delta weights, and yeah, basically these synapses have come to the conclusion that yeah, we're way too high, like we need to be decreased so that it works better next time. So yeah, let's see how they update. So yeah, basically they have been decreased by a big amount, and then let's run through the data one more time and see how the MSE becomes with the new weight. So yeah, it has decreased by a big amount, and then we update again, so they have become even smaller, and now it's like pretty close to 0. So you can see, like for this data, it's super easy for the network to find a solution. But yeah, like this is not going to work if we have more complicated data. And I'm changing now the data from these float values to integers, because I realized that it's like automatically going to convert these to floats, so we can actually write like this.